Alright, so in this video we're going to take a look at one more kind of interesting problem that we could run into with numbers in programming. So for this one specifically, what we're going to be looking at is issues with the accuracy of our fractional or decimal representations in our computer systems. So the way that I've described this, the title that we have here is Precision using our BigDecimal class. So we're going to introduce another class in this example. But before we get into that, I want to take a quick look at this set of lines that I've got here. So we're going to declare a couple of doubles. So we've got one that we call dollar that we will use to represent $1. We then have another double called dime. We're going to use that to represent 10 cents or just 1 dime. And then we have one more number. This one's going to be an int. This one's basically going to be the amount of dimes. So in this case, we're going to do it with 7 dimes. And then we have a print statement. So we're saying that we want to print out the statement $1 minus, and then the number of dimes. So $1 minus 7 dimes is, and then we want to get the result of that. So the very last little part that we see in that print statement, we're doing $1 minus number times dime. So number times dime is going to give us 70 cents. And then we're just taking that from $1. So we're going to be left with 30 cents. So the expected output of the statement should be the statement we have right here, $1 minus 7 dimes is 30 cents. So you have the $sign 0.30. But what is the actual output of the program? So to answer that question, let's go ahead and write this out and see what the actual output for this program is. So go ahead and minimize this. I'm going to go ahead and do NetBeans, and we'll go ahead and create a new project, make this a Java application, click Next. And for this one, since this is going to be to demonstrate the use of the BigDecimal class in order to correct this problem that we're going to see in a moment, I'm going to call this my BigDecimal demo. So do something like that, click Finish. And then inside of our code, we'll go ahead and remove the extra parts that we're not going to need. And then right here, we'll go ahead and write out those 3 variable declarations, so our 2 doubles and our int, and then we'll also include that print statement. So we're going to have our double, we'll call this $. This is going to have a single dollar, so 1.00, assigned to it. We'll then go ahead and do another double for our dime. And for this one, we're going to assign that 0.10, so 10 cents to it. And then finally, we'll have our int for the amount of dimes. We'll call that number. This will be equal to 7. And then once we've got these 3 variable declarations, we'll go ahead and include that print statement. So we're going to say system.out.println. And then right here, we'll go ahead and put in a $, minus plus our number, and then dimes is, and then we'll have a $sign right there, and then right here we'll have that pair of parentheses, and inside of this we're going to put in our $, minus our dime times our number. Okay. So when we run this in a moment, we want to get this print statement to print out. So we're doing a $, minus. We're using string concatenation to combine our string literals and our variables. The first variable we're putting in is the number, so 7. So we're going to say a $, minus 7 dimes is, and then a $sign, and then we're doing that math operation. And in order to make sure that we understand that we're performing a math operation here and not just concatenating all of these different numbers to our string, we're not doing something like 1.000.107 or something like that. To very clearly indicate that these are math operations we want to perform, I'm putting an extra set of parentheses around that portion of my, my print statement. So now we'll go ahead and run this, and let's see what the actual output is. So when I do this, we see that we get a $, minus 7 dimes is, and then for me it's going to say 0.2, and then a bunch of 9s repeating, and then a 3 on the end. So obviously, we all know basic multiplication and subtraction. We probably realize that this is not the correct answer. It should be 0.30. So then, of course, the question is, why is this the answer that we're getting? So If we come over here, I have a link that I provide right here that gives you a very detailed answer of this. So we'll go ahead and open this just briefly to see this. And so in this particular example, the person is doing 0.1 plus 0.2. For them, they're getting 0.3 and then a 0 repeating and then a 4 on the end. So again, they get a number that's almost 30 but not quite, and then they get this weird, very precise number. There's a lot of decimal points there, but it's not quite the right answer. And if we take a look at the top answer for this, so you'll see this person right here starts to break down precisely what the problem is. And if you want to take a look through the entire explanation that they give, you can either check the link, or if you're not using the slides, then you check something like the title of this. So you'd say, is floating point math broken? That should help you find this. But this person goes into a lot of detail about this as they kind of break everything down. So I'm going to try to summarize everything that they talk about. I believe that they also get into a couple of other additional points besides just the problem that the person is running into. But to summarize this problem in about 4 sentences instead of about 5 paragraphs, we've got that all of our data is going to be stored in our computer in binary. So we know that in a computer system, everything is in a bunch of zeros and ones. For integer values, it's fairly easy to store that integer number, just taking its decimal representation and then converting that to some binary representation. But for decimal numbers, it's much more difficult to accomplish this. There's going to be some degree of inaccuracy. And the reason for that is that when you have a decimal number in binary, there are certain fractions that will fit perfectly. So that's going to be things like multiples of 1/2, 1/4, 1/8, so all these negative powers of 2. But if you're dealing with something like 3/10, well, there's no combination of adding, like say, 1/4 plus 1/8 or so forth and so on, that's going to give you exactly 3/10. So instead, what your computer has to do is just kind of approximate it to the best of its ability, and that's why you get these answers that are very close to 3/10. It's almost 3/10, but it's not quite 3/10 because of this, this inaccuracy in its representation. So in order to fix this, we're going to use the BigDecimal class. So that BigDecimal class is going to come from our from the math library. So it's that java.math.bigdecimal. So we're going to go ahead and include this as an import in our program. So for our BigDecimal demo, we're going to then modify the main method. So you'll see here, instead of using double for our dollar and dime, we're now going to create these objects of our BigDecimal class. And for each one of those, we're using a string with the number that we had before to serve as a representation of that number. So in this case, we see our dollar, we're going to do new BigDecimal, and we're going to say the string with 1.0. For BigDecimal dime, it's going to be another new BigDecimal, and we're saying string 0.1. And then in our print line statement, we're doing a dollar minus. We still have that concatenation with our number. Then we say, so a dollar minus 7 dimes is, and then a dollar sign. And then we're going to replace the just the simple math operations we were doing before with all of these different method calls to some methods of our BigDecimal class. So we'll go ahead and recreate all of this. So we're going to be using things like the subtract method and the multiply method. We'll also convert number to a BigDecimal for the sake of being able to print it or be able to use it in these operations. So let's see if we can go ahead and reconstruct this. So we're going to go ahead and modify everything in this program now. So we'll go ahead and import from the math class our BigDecimal, or from the math package, I should say, the BigDecimal class. From there, we're going to modify dollar and dime. So this one's going to be from double to BigDecimal. And same thing with this one. And then on this side, instead of just assigning some numeric literal like 1.00 or 0.10, we're going to make these into objects of the BigDecimal class. So we'll say new BigDecimal. And then we're going to go ahead and put that string in there for 1.00. We'll go ahead and do the same thing with this one. We'll say new BigDecimal. And then we'll put that string into that method to go ahead and make our two big decimal objects. And so then when we do that, we're going to see an error on line 13 because now we need to modify all of this stuff. It no longer recognizes it, or it can no longer perform these operations because these are objects of the BigDecimal class. So what I'm going to go ahead and do is move this part to the next line since it's about to get a little bit longer. And then right here, so the order of operations tells us a little bit about the order that we want to try to do these calls in. We know that our subtraction is going to occur at the end, so we're going to do that after we've done our multiplication between these two numbers, that dime and that number. So if we're using dollar, right here is our object, we want to call the subtract method on it, so we'll get that. If we do that, we no longer need this $sign here. We know that we want to use the dime as part of it. We also need to use number. So we want to create a new number object, or a new BigDecimal object using number. So I'm going to go ahead and remove the rest of this now. So we'll go ahead and add that right here. Say new BigDecimal. We'll just go ahead and make this object right here in this print statement. And it's going to be made from number. And then we want to go ahead and use the multiply method. And with that, we're going to use the dime. So it went ahead and autofill it for me, so I can just remove this extra one. And make sure that I have all of the parentheses. And, oh yeah, there's one more for the print line statement. Okay. Okay, so now we have everything. So we're going to do new BigDecimal with number.multiply dime. If we keep track of the highlighting that it does for us, we can see where all these parentheses are meant to go. So this first pair of parentheses is just around the dime that we're passing in to our multiply method. This next pair of parentheses is for this whole multiplication that we're doing inside of the subtract method. The next pair of parentheses is to indicate where we're doing all of our BigDecimal operations, so kind of separating those from the rest of our print statement. And then that last pair of parentheses is for the print statement itself. So now if we go ahead and do things this way, go ahead and run this. Now we can actually get the correct result for this. So to say $- minus 7 dimes is 0.30. So get the correct result without any of those inaccuracies. So this is going to wrap up everything for the BigDecimal class. Getting into the next video, this will be the final video for all of the Chapter 2 content. And in that video, we're going to take a look at dialog boxes as another way that we can go about providing some user input to our programs.